Coulomb's law, scalar form. It is applicable for point charges. Point charges means when separation between two charges is very much large compared to their own sizes. Like Earth is quite big, Sun is also big. But compared to separation between both, their own sizes are small. So Earth and Sun both are called point particles or point objects. Likewise, when separation between two charges is very large, that separation is small r. Charge 1 Q1, charge 2 Q2. So, electric force between two such charges is directly proportional to Q1 Q2, multiplication of the charges, and inversely proportional to square of distance between them. Now, when equal to is introduced by removing proportionality sign, one constant also comes. That constant is 1 upon 4 pi epsilon 0. If both the charges are in air or vacuum, then this force is force between two charges in air, and epsilon 0 is electrical permittivity of air. If the space between both the charges is completely occupied by some material, then force in that material or medium is equal to 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon q1 q2 upon r square. We take permittivity of that medium. Fm is force between two charges when they are in medium. F is force between two charges when they are in air. Force in air, electrical permittivity of air. Force in medium, electrical permittivity of that same medium. What is electrical permittivity? It is explained in previous video. Video number 12.1 BC3. Standard 12, chapter 1. BC means board concept, and video number 3. So, this is Coulomb's law. Now, 1 upon 4 pi epsilon 0. This combination is called electrostatic constant or Coulomb's constant. Coulomb's constant or electrostatic constant, denoted by small k. Now, in the previous video, that is board concept number video number 3, we have learned that electrical permittivity of any medium upon electrical permittivity of vacuum is relative electric permittivity of medium, also called capital K, dielectric constant. So epsilon is equal to epsilon 0 into epsilon r. Epsilon is equal to epsilon 0 into epsilon r. Now, if we ignore this term, then rest of the combination is force in air. So force in air upon epsilon r. Epsilon r is also capital K, dielectric constant. Small k is Coulomb's constant. Capital K is dielectric constant. This is capital K. Okay. So force in any medium between two charges is equal to force between the same two charges in air divided by dielectric constant of the medium. So when two charges are transferred from air to some medium, the force between them will reduce. How many times? K times. K is dielectric constant of that medium. Epsilon 0 is electrical permittivity of vacuum. Its value is 8.854 into 10 power minus 12 Coulomb square upon Newton meter square. Where does this unit come from? So, F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. Now, if we exchange F and epsilon 0, then Q1 Q2, Coulomb into Coulomb, Coulomb square. Force is Newton. R is distance between two charges. So R square is meter square. Okay. Now Coulomb's constant K is equal to 1 upon 4 pi epsilon 0. If we put value of epsilon 0, we get value of small k nearly equal to 9 into 10 power 9. Unit Newton meter square by Coulomb square. Reciprocal of this. K and epsilon 0 have inverse units because 4 pi are unitless. So the unit of K is reciprocal of unit of epsilon 0. Upside down. Newton meter square goes in numerator. Coulomb square comes in denominator. Now, if you remember from what we studied in previous video, then relative electric permittivity of any medium is equal to electric permittivity of that medium upon electric permittivity of vacuum. So, for water, relative permittivity is electric permittivity of water by electric permittivity of vacuum. And this is nearly equal to 80. Electric permittivity of air, relative electric permittivity of air is electric permittivity of air upon epsilon 0, which is 1.00059. For vacuum, relative electric permittivity is equal to electric permittivity of vacuum upon electric permittivity of vacuum. Epsilon 0 by epsilon 0, that is 1. For the metals, this dielectric constant or relative electric permittivity is infinity. Why it is infinity? For that, we will make a separate video which will belong to chapter 2, chapter number 2. So, we almost take air is nearly equal to free space. It is almost similar in behavior to vacuum. Its behavior to the passage of electric field through it. Now let us discuss some characteristics of Coulomb's law. So Coulomb's law is a fundamental law. Very basic law. All charged particles obey this law. So it is fundamental, but it is not universal law. Universal law is a law that is applicable in entire universe, anytime, any situation. But Coulomb's law is conditionally valid when charged bodies are massive, large, compared to the separation R between them. Such bodies are not called point charges. When size of charged bodies are very small compared to separation between them, they are called point charges. So Coulomb's law is valid only for point charges. This is one condition. That is why it is not universal law. Also, This law is valid only when separation between both the charges is greater than 10 power minus 15 meter, that is 1 Fermi. For the separation less than this value, this law is not valid. So this is property number 1. It is fundamental but not universal. Next property, that Coulomb's law is a central force. Coulomb's law is a central force, which means that if these are two bodies, suppose point bodies, point charges, then think of a line connecting their centers. If both are positive, they will repel each other. First body repels second in this direction. Second body repels first body in this direction. So both the forces act on the line, and that line joins the centers. This is the meaning of the statement that Coulomb's force is a central force. The force which acts on the line that joins the center, is the meaning of central force. Third property is Coulomb's law is inverse square law. Inverse square law. Why? Because F is proportional to Q1 Q2 upon R square. The force inversely varies with square of the distance between 2 point charges, is the meaning of inverse square law. Fourth property is Coulomb's force is a conservative force. Now what is conservative and non-conservative is a topic of standard 11th chapter work, energy and power. So we will not discuss here, but I think you must be knowing it. A force is called conservative if work done on a particle by that force or inside the field of that force depends only on the initial and final position of the body, but doesn't depend on the path taken between those two positions. Such force is called conservative force. Fifth information about Coulomb's force or Coulomb's law is the force between two particles, charged particles Q1 and Q2, which is Coulomb's force, that is given by F equal to small k Q1 Q2 by R square, is very weak force. Although it is quite stronger than gravitational force, but yet it is very weak force. We cannot feel it. So how scientist Coulomb might have estimated the value of the forces between different charged particles? The answer is by using a special torsion balance. Torsion balance. Now what is balance? This is a balance. Okay. 1 kg apple, 1 kg weight. So a tool used for measuring the weight or mass is called balance. Now what is torsion balance? How does it work? How is the construction? Again, we won't discuss in detail because I don't think it is much useful. It is never asked. Last property, which is very important, F is equal to K Q1 Q2 by R square. Now if both the charges are like charges, Like means both are positive. Then plus into plus is plus. If both the charges are negative, then also they are called like charges. Then minus into minus is also positive. So for like charges, the Coulomb's force is positive force. For unlike charges, one is positive, other is negative. They are called unlike charges. So plus into minus is minus. So for unlike charges, Coulomb's force is negative force. So that's all for this video. We will meet up again in the next video. Till then, stay happy, stay healthy, keep learning, keep studying, grow in the life. Bye bye.